Hi there. Well, what we're going to look at now is section 3.3. And this is on linear equations. What is a linear equation? And we're also going to look at another method of graphing that we did not talk about in 3.1 and 3.2. So to begin with here, you're going to have to ignore the date there, but they want to talk about what is a linear equation. And in order to be a linear equation, when you graph the solutions, it would form a straight line. See, thus we have the word line in this one right here. This is a basic form of a linear equation where A, B, and C are numbers. So here, in order to be a linear equation, the X and Y have to be to the first power, and they have to be added or subtracted to each other. So they can't be multiplied. And we'll do an example here in a minute. So which of the following are linear equations? Well, this one is a linear equation because first off, the X is to the first power, the Y is to the first power. And you're asking yourself, well, are they being added or subtracted? They do fit the first part in that they are to the first power. Well, if you were to subtract 3x to both sides, if we were just to move it and rearrange the equation, we would have a minus 3x, and this would be plus y because you could not add those together, and then negative 5 would be there. So, really it does fit, this right here does fit this form right here. So as long as they're on opposite sides like this and to the first power, then yes, if you were to graph the solutions, it would form a straight line. Now, B, we did talk about in the last section, because it's a squared, it is not linear. This is a parabola. Anything to the third, the fourth, the fifth. Whenever this is not a 1, it's not linear. So this would actually form a parabola. But what happens if you're looking at C and D where we're actually missing either the X, as in this case, or we're missing the Y here? We're missing this Y as in D. These two are both linear. So even though you're missing a variable, the variable you do have is to the first power. So both of these are linear, and they form special equations, which we'll look at extensively later on in this section. So again, they have to be to the first, okay? And they have to be able to be added or subtracted, or you can be missing a variable, and it will still be linear. As I stated before earlier, X times Y equals some number, okay? This is not linear. Even though they're to the first power, they're not being added or subtracted. When they're multiplied, this is not going to form a straight line when you graph the solutions. Okay. All right, so now we're going to kind of skip here. We're going to talk about intercepts. And when we talk about intercepts, we're wanting to know where does it hit the x-axis or the y-axis. And sometimes they won't hit the x-axis, sometimes they won't hit the y-axis, depending upon the equation. So intercepts are places where the graph of any function crosses the x-axis or the y-axis. So an example of the x-intercept here is, as an example, we would want to know where does it cross the x-axis. That would be the x-intercept, and how to find that. Y-intercept, again, if we're looking at a y-intercept, here. Okay, that would be an example of a y-intercept where it's hitting the y-axis. Now, when you want to look at the x-axis, whenever it crosses the x-axis for the x-intercept, there's something about the ordered pairs along the x-axis. So here, I'm going to kind of re-graph this here. we're going to look at points along the x-axis. Now, when we want to find the x-intercept, it's going to hit along here. Now, if you look at these ordered pairs, this is the ordered pair 1, 0. If you looked at this one up here, I'm going to put it above. This is the point 2, 0. Here, this is the point 3, 0. And you start to see a pattern within these points where it's hitting the x-axis. You know, maybe it's here. Each of these lines is hitting the x-axis. And notice that the y-coordinate is always 0 when it hits the x-axis. So that helps us later on when we're given the equation and not the graph. So when you have the x-intercept, the y is always going to be equal to 0. Okay? Any point along here has a y-coordinate of 0 because you're not going up or down. You're staying on that x-axis. And the y-coordinate always tells you how high up to go. But what about the y-intercept? Well, if we look at the y-intercept and where it's hitting the y-axis, it's going to hit at a point here. And if you look at these coordinates, this would be 0, -3. Let's go to this one up here just to kind of keep it looking a little bit better. That's the point 0, 1. So if you'll notice all of these, 0, 1, 2, 3, 4. The y-intercept, all the x coordinates are 0. So that's going to help us, again, given an equation, find the x-intercept, and given the equation, find the y-intercept. These ideas will help us right there. And again, these would be crossing the y-axis at those points where the x is always 0. So let's go ahead and look at some examples to try to clarify that idea that we just talked about here. Looking at this, what are the x and y intercepts of the graph below? Well, here, it's going to, let's find the x-intercept first. And when you're given a graph, it's pretty easy. To find the x-intercept, we go along the x-axis to see where it hits. And it looks like it's hitting 1, 2, 3. So it hit the x-axis at 3. Now they may ask you for an ordered pair. So we know that it would be 3, 0, because when you have the x-intercept, the y is always 0. That's the ordered pair. Or it may just ask you, where does it hit the x-axis? And you would put 3. So you have to look at Pearson when you're doing this to see how they want the answer. Do they want the answer as an ordered pair, or do they just want the 3, x equals 3? Okay, now to find the y-intercept, it's where it hits the y-axis. All right, that would be here. It looks like 1, 2, 3, 4, 5, 6. So it's hitting the y-axis at 6. So how do you write that as an ordered pair? 0, 6. Because when it hits the y-intercept, the x is 0. So that would be the y-intercept 0, 6, or it just may say, where does it hit? And you would just write 6. It may ask for an ordered pair, or it may just ask the number where it hits the y-axis. All righty, good. Let's look at a parabola. So any type of equation, whether it's a parabola or whichever, has x and y intercepts. Let's look at this example of this parabola. Now I know here's the y-intercept. The y-intercept is the point 0, 4. And Pearson may ask you to list the intercepts. If it just says list the intercepts, and they may say list the x and y intercepts, it doesn't matter the order, you can find the y's and then you find the x's. So here's the y-intercept. I'll just go ahead and label it y-intercept. but I'll also give you an idea of how to enter your answer. Now the x-intercepts are -2, 0, because I know that when you find the x-intercept, the y is 0. The y-intercept, the x is 0. There's always opposite. And it also has an x-intercept at 2, 0. So if Pearson were to say, find the intercepts, you would type in 0, 4 as an ordered pair, comma, -2, 0, comma, 2, 0. Those are the intercepts as ordered pairs. Here's the y-intercept, one, it hit the y-axis in one spot, but the x-axis, it hit in 2 spots. All righty, good. Now what we're going to do is we're going to look at that method that we kind of skipped in 3.1 and 3.2, and that is how you can use the intercepts to graph an equation. Now, this depends on the equation, whether or not you would want to use this method. So looking at this, I would only use this method of graphing, and it's a very quick method of graphing, if these two numbers in front go into this one over here evenly. That's when I would use the x and y intercept. 2 goes into 20 and 4 goes into 20. And we're going to look at one where you wouldn't want to use the x and y-intercepts to graph it. But this one we do because 20 can be divided by 2 evenly, and 20 can be divided by 4 evenly. So let's go through our process. First off, it doesn't matter which one you find, either the x-intercept first or the y-intercept. Let's find the x-intercept. If you want to find the x-intercept, I know that the y is equal to 0. Again, it's always the opposite. Let me move this up a little bit. I kind of like this method, so. Because it can be quite a bit easier than using the slope-intercept method. So now here we know that the y is 0. So looking at this equation, I know that the y is 0. So that whole part drops out because 4 times 0 is 0. So we're just left with 2x equals 20. Divide by 2, x is 10. So I know that it will hit the x-axis. Let me see, where can I put this so it stays organized? I guess I'll go clear over here. It hits the x-axis at 10. Okay, you'd make a dot at 10. Now, what about the y-intercept? So we have 2x plus 4y equals 20. In order to find the y-intercept, I know that x equals 0. If x is 0, that whole thing is 0. 2 times 0 is 0. So 4y equals 20. Divide by 4, y is 5. So it hits the y-axis at 5. And then you make a dot, and then Pearson actually, it'll graph the line for you. And there's your equation. So it can be quite easy, because what you'll do is you get more used to this method rather than writing it out every time. You know that when it hits the x-axis, the y is 0, you can just cover it up. 20 divided by 2 is 10. So it hits the x-axis at 10. Got the snakes. Oh my goodness. And now when you want to find the y-intercept, you make the x 0 and you can just cover it up. 20 divided by 4 is 5. So it hits the y-axis at 5, and it's easy to plot those. Now, is that the only method? No, you could have used the t-chart. You could have solved it for y. And that's what a lot of you are used to, is solving that for y. And if you solve it for y, we have, let's just go ahead and look at that method. So you can see that there you have different options here. To get the y by itself, you subtract 2x. This method is using the slope-intercept method. So we have 4y equals a negative 2x plus 20. Now, again, I usually put that in front. You could put it behind. It's up to you. Divide by 4. So then y, I'm going to come over here because I don't want to get here in this area here for this next one. Y equals negative 1/2 x, negative 2/4 reduces to a negative 1/2 plus 5. So again, you would go to, this is the slope intercept, you go to the 5 on the y-axis, make a dot. You would go down 1 because here's your slope. There's your b, here's your m. Here's your slope of a negative 1/2. It's rise over run. So from the 5, which we have plotted up here, down 1 to the right 2, down 1 to the right 2. And you end up with the same line. I feel like this one just takes a little bit longer than actually this method right here. Okay. All right. Let's look at this next example. I'm not going to do this method. I'm just going to do using the intercepts. So again, to find out where it hits the x-axis, y is 0. So that term drops out. So the x-intercept, I'm going to go through it step by step. I guess I can. So y equals 0. So you're left with a minus 4x equals 24. Divide by a negative 4 to find out what x is equal to. X is a negative 6. So again, you divide by negative 4 to get the x by itself. I will hit the x-axis at a negative 6. Right there, negative 6. All right, where is it going to hit the y-axis? Well, x equals 0. It's always the opposite. X-intercept, y is 0. Y-intercept, x is 0. If the x is 0, that means that first term is gone. So you just have 6y equals 24. Divide by 6. Y is 4. So it's going to hit the y-axis at 4. And there's your graph. So I think it goes quickly. But again, you only want to use this method, and I kind of skipped this idea of deciding what method I want to use. If you're using the x-intercept, make sure that this number can be divided by these two evenly, even if it's a negative. 24 divided by this is a negative 6. Okay. 24 divided by 6 is 4 on the y-axis. So you want to make sure, because fractions, Pearson doesn't work well when you're graphing with fractions. So sometimes it does, but most of the time it won't. Great. So let's look at this example right here. We're almost done. Here it says, graph this using intercepts. Now that actually should have been a question mark here. Do you really want to use the method of intercepts? Here, negative 9 is divisible by 3, negative 3, no problem. But 9 is not divisible by this number. So I would not use this method. Do not use this method as far as finding out where it hits the x-axis and the y-axis and plotting those 2 points. This right here, you could use a t-chart and pick, some numbers. I would probably get the y by itself and use the slope intercept method. So this gives us an opportunity to go through that method a little slower. Again, I'm not really sure some of your backgrounds in math. Some will have more than others, so we'll go through this a little bit slower. Yeah, -9. I did copy it down right. All right, the first thing you do for this method, because we're not using the intercept method, finding out where it crosses the x and y axis like we did last time, what we're going to do is we're going to get the y by itself. So to do that, we're going to bring this to the other side by subtracting the opposite. I should maybe get some colored pencils. That might help. So we have a -3y. Obviously, these cannot be added together because they're not similar. I'm going to put this one first because it just fits the slope-intercept form. And I'm going to leave the -9 right there. Okay, now to get the y by itself, we'll divide by a -3 every term, or both sides is the same as the every term. So I divide by a -3, divide by a -3, divide by a -3. So y equals, let's look at our first term, -5x over -3. This number in front of the x represents our slope, so we will leave it as a fraction. Don't make it a decimal. So we will leave that as a positive because a negative over a negative is a positive. So there's our first term. Then here we have a -9. This represents a negative divided by a -3, gives us a +3. Now I will use this to graph the equation. And I'm using this method. I think it takes a little bit more time, but in some cases you need to. This will cross the y-axis. Remember this number here, we use the symbol B for it, whereas this number here is the M. And the y has to be by itself in order to use this method. We will go to 3 on the y-axis. So this is always the y-axis. And again, I've stated before in the last video that the mistake that people make is they'll go to here on the x-axis. So make sure that this number is 3. Make your dot on the y-axis. Then your slope, this is rise over run. So you're going to go up 5 because it's positive, and to the right 3. So I didn't really leave myself a lot of room. But. So you'll go up 5, 1, 2, 3, 4, 5. And again, I started at my y-intercept, 1, 2, 3, 4, 5, and over 3, 1, 2, 3. So the slope is a path, rise over run. Okay, and then Pearson will connect it up for you. So I guess I should probably be using a ruler. All righty. So again, that's using the slope-intercept method because 5 did not go into -9. All righty, let's try another one here. Let's graph 3x minus 2y equals 60. What method do you want to use here? Do I want to get the y by itself and use this one, or could I use the x and y intercept? Well, 60 divided by a -2, it's even, happens to be a -30. 60 divided by 3. All right, so they both of these numbers go into this one evenly. So we're going to use the x and y intercept method. We're going to do the x-intercept by making the y equal to 0. When you make the y 0, this term disappears because -2 times 0 is 0. That leaves you with 3x equals 60. Divide by 3 both sides. X is equal to 20. That's where it hits the x-axis at 20. So you'd make a dot on the 20 on the x-axis, and we'll do that here. But let's go ahead and find the y-intercept, and then we'll just do them both. Okay, the y-intercept, you make x equal to 0. If the x is 0, this term is gone because 3 times 0 is 0. So we're left with a negative 2y equals 60. Divide by a negative 2. Y is equal to a negative 30. So this is where it's hitting your x and y axis. So at x equals 20, now you'll have to, when you're looking at Pearson, make sure that that you pay attention to the grid marks. So we'll just go we'll go by tens. So it hits the x-axis at 20, and it's going to hit the y-axis at a negative 30, negative 10, negative 20, negative 30. Okay. And then Pearson will connect it up once you plot those 2 points. Okay, so that's kind of a review of how to find the x and y intercepts and use that as a graphing tool. All righty. Now what we're going to look at, a couple of special equations. And like I said earlier, if you're missing the x, it's still linear. If you're missing the y in the equation, it's still linear, as long as the x and the y are to the first power. But what do they look like when you graph them? And how do you graph this, when, we're not going to use the x and y intercept method. How do you graph y equals 3? It's pretty simple. If y equals 3, and there's x is gone, it just means that x can be anything. It means that you could have the point 0, 3, 1, 3, 2, 3, negative 10, 3. As long as the y is 3, that's the only parameter that you must adhere to. It's the only constraint. So we've got 0, 3, 1, 3, 2, 3, negative 10, 3. What does that look like? What does the picture look like of all the solutions? Let's look at them. We've got 0, 1, 2, 3. So we have x is 0, y is 3. X is 1, 1, 3, 2, 3, negative 10, 3. So we have a horizontal line at 3. So it hits one way I remember it is that it's going to hit the y-axis at 3, and it goes across. All righty. But these are some points that you could plot if you needed to. So on Pearson, if you're given this equation right here, you would just go like, 0, 3, and then like 1, 3, and make another dot, and it'll draw it for you. All right, now let's look at this one right here. X equals a negative 2. What does this mean? That in the ordered pairs, as long as x is a negative 2, because y is not in the equation, y can be anything you want. You can make any number you want because it's not in the equation, as long as x is a negative 2. What does this look like as a picture? So we'll go to a negative 2, negative 2, 0, negative 2 of 0, negative 2, 1, negative 2, 3, 1, 2, 3. So you can see, well, what we're getting here is a vertical line. So the last one was horizontal. This one is a vertical line. And notice that it hits the x-axis at a negative 2, which is one way to remember that. Or you can come up with some points. Okay, perfect. Let's see what we've got on our last page here. Graph x equals 6. Well, we know that x equals 6. We're going to go to the x-axis. We're going to go to 6. And we know that this is going to be a vertical line. As long as x is 6, y can be, you can have 6, 0, 6, 2, 6, okay? but it's a vertical line through x equals 6. These are pretty simple. Y equals a negative 10 if you were asked to graph that one. I'm going to go to the y-axis. This is not, it's kind of a fluffy table. So let me put some of these. So I'll go to the y-axis at a negative 10. And it will hit the y-axis at a negative 10. It's a horizontal line. And this just means that x can be anything. And you could go 0, negative 10, which is this point. You could do 1, negative 10, 1, negative 10, which is this point right here. So you, couple of points there. Okay, so now, last thing, what if I give you the line, either vertical or horizontal, what would the equation be? Well, here, this one hits the x-axis at 4. So this is x equals 4. You're done. All righty. Let's look at B. This hits the y-axis at a negative 5. There's your equation. All right, let's look at C. This could be, what is the equation of this right here? This actually is the equation of the x-axis. So if they ask you, what's the equation of the x-axis? Well, it hits the y-axis at 0. So this is the equation y equals. Notice these horizontal lines are always y equals. Horizontal lines are always y equals. It's hitting at 0. Look at the points. This is the point 1, 0. You're not going up or down. 2, 0. 3, 0. So all of these have a y equals 0, but the x can be anything. So the equation of the x-axis is y equals 0. Now, this one right here, this is a vertical line. Vertical lines hit the x-axis. It's hitting the x-axis at 0. So the equation of the y-axis is x equals 0. This is a vertical line. Okay, so this is the equation. I'll write it out. Of the y-axis is x equals 0. Because the y-axis forms a vertical line. And they're always x equals. It hits the x-axis at 0, the y-axis at 0. All righty. Well, that pretty much does it for this section. And again, I encourage you, if you have any questions at all, to contact me, and I can help you out. If, I've gone through this. It's kind of supposed to be a review, but if it's been a while for some of you, don't stress about it. Just let me know. All right. Bye-bye.